And please feel free to ask question. Today we are discussing very important topic, which I'm sure all of you would have heard about and also possibly used it. Some of you, out of curiosity, might have used it, right? So we're today discussing about Bitcoin and blockchain. So we'll have this lecture. Uh, the contents of this lecture will continue in the next class. Okay, all right. So these are the references that I have used. It took quite some time to understand the concept. There may still be some gaps in my understanding, so you may correct it if you could find it. But there's no substitute to reading it directly from book or papers. So these are the contents we'll take up today. We'll try to finish up to this point, and if time permits, we'll also look at identity management for Bitcoin. Okay, all right. So these are the two main references on Bitcoin and blockchain. The book by Narayanan, who was fortunately my student sometime in 1992 in IIT Madras, wrote this wonderful book, this kind of classical book. So it's available for free, downloadable version, so you can download it if you want. This book is also quite nice. Okay, apart from that, I've used large number of PowerPoint presentation by various authors to take out some contents like diagrams, etc. Okay, please go through this too. Okay, so Bitcoin and blockchain technology, primarily Bitcoin, is based on three main things, right? Cryptography, distributed systems, and economics. Okay, cryptography you have already understood. Distributed system as part of networking you have understood, but not fully, but to some extent. Okay, important property in general of a distributed system is that there is no single point of control. In a client server, for example, or some other mechanisms, right? There is a central server that connects to many clients, right? Or for example, many other systems, right? Traditional systems are all based on some master and slaves. Okay, but in distributed system, everyone has the same power. Kind of everyone has the same power, right? There is no something called central entity. Okay, so these are all connected to each other over internet or as distributed systems, and then if the decision is to be taken, then it is taken jointly, collectively. There's a difference between centralized system and distributed system. Economics you would have studied as part of your course. If not, then don't worry much about it. Cryptography, by now you have understood almost not everything, but main components of cryptography, right? Okay, all right. So suppose you are the master now. The great gentleman Satoshi has designed this, and nobody knows who the Satoshi is. He wrote a classical paper based on this thing started. Assuming yourself as Satoshi's son, and then think, if you are going to design a cryptocurrency, what all you are going to have? Okay, anybody? You would have used cryptocurrency, you would have read a lot of articles about it. What is necessary for any currency?
User
That's
base.
it. Yeah, go ahead.
User base.
User base is, yeah, that's okay. Some set of people should use it, right? And should increase. But apart from that, what is it? What is it required? User base, very right. Users, right? what is a currency and what should a currency do? It should, somebody has to produce it, right? This is absolutely, crypto is absolutely democratic way, right? Here, who produces currency in real world, today's world, right? Countries, right? Now here in cryptocurrency, who can generate cryptocurrency? Who can mint crypto coins? Everyone. You can create cryptocurrency, crypto coins for a crypto, for Bitcoin. So everyone can create coin, crypto coin, right? Bitcoin. Then, if it's given power to me that I can create any number of crypto coins, then I will do it. Then the whole game will be over. If anybody can create any number, then the currency has no value, right? It means that somebody has to spend something to create it. Like in traditional, real currency, you look at some assets, right? And based on that, government can create it. Like, for example, gold or whatever. You can read about, what is actually normal currency is and how governments decide. Otherwise, country like Pakistan, where there is value of Pakistani rupee is appreciating every day, can just mint, right? They can mint more currency. So there is some basis, right? So here, when we say everyone can do it, there must be some basis. So you have to spend something. Okay, what do you spend here? What as user like you can spend? What do you have which you can spend and create crypto coin? Think about it. You have very important asset which you are not using almost like 70-80% of time, maybe 90% of time.
Processing
Maybe,
power.
pardon? Yeah,
Processing power.
very good. Computing cycles. Very good. Your machine, you're not using computing. So now crypto, this set of people who run crypto, you can also be a part of that group. Every day they will say that solve a quiz, okay, is a puzzle, and everyone has can participate in the puzzle, and you solve the puzzle, and this puzzle is based on how much computing power you spend, okay, and you hit upon the solution, then good, you get part of Bitcoin. Okay, so everyone can participate in getting a part of cryptocurrency. So when you are not using a laptop or even as a background process, you can continue to run this, and after a few years you will find that you have something. All right, what else is the property of crypto? If you're generating a coin, what can be? So look, if you participate and think, then most of that lecture is done. Okay, now one thing that we notice is that everywhere in the current currency, right, suppose I ask you to transfer money to me, okay, can you do it without anybody knowing about it? When you say anybody, it means that your bank will know, right? You will either do bank transfer or you will do, bank transfer is ultimately controlled by government or banks, okay, in some sense government. And then if you do say I can do a Paytm, of course Paytm folks will know that you have transferred it, right? Okay, so it's not truly independent, a system where nobody knows that you are transferring money to me. Okay, so I want that anonymity, 100% anonymity, that nobody, including government or banks or an agency, will come to know. Okay, so anonymity can be second one. What could be other? there should not be any transaction fee. See, how does bank make money apart from giving loan to you? When even if you transfer money from A to B, they take some part. That's the reason Government of India came out with UPI and all that, right? So the bank's share reduces. Otherwise, simple making, when I transfer 1 lakh from one account to, one bank to another bank, or to Amazon.com, then I see that some money is gone. And when you do Forex exchange, INR to, for example, USD, then you see that 2 or 3% goes off, right? All this is not required. So this should almost be free. No fee or free. What else? There may be another properties of, now it's a digital money. So it has to work on internet, right? So anybody who does not have internet cannot participate in that. And then other things, right? Suppose you sent me this money, who's going to keep track of that? Now there is no central agency, right? And I have this money. What is that money? That's the first question you ask. And then how, suppose you have transferred to me 1 Bitcoin. Can anybody transfer me this Bitcoin? So that person must be having a Bitcoin to transfer me. And secondly, once I have suppose 5 Bitcoins, can I spend it 10 times of that? See, so when you use normal currency, then you have 100 rupees. You cannot 5 times, you cannot spend that 100 rupees. You cannot give it to 5 different people, 100. You can't make 5 copies. In digital, you can make multiple copies. Okay. In digital, like a Microsoft Word you can make 5 copies. So there should not be double spending, right? And then all these transactions that are happening, that you're transferring money to me, must be recorded somewhere. And this recording must be done in distributed way, such that there is no single owner of this. And it has got to be democratic. Everyone should be able to see it. Now, I also want anonymity. If nobody wants to see it, I don't want that you have transferred money to Ravi. Right? It means now it has to be based on keys, some number, and that number should always change, can always change, right? So now my identity will be based on my key that I hold. And what is going to be this key? What is going to be this key? Like a private key, for example. Okay, so now we have answered almost everything. There are very few things about cryptocurrency, not everything. Okay, all right. Any question? No? Shall we go ahead? So now we already have foundation to understand cryptocurrency. When you use the word crypto today, then nothing but Bitcoin and cryptocurrency comes into our mind, right? Okay. Had you used the word crypto 20 years back or even 10 years back, and somebody who is aware will think it's encryption or something like this. All right. So today crypto means the crypto money, cryptocurrency. So what are when we say crypto building blocks, what are the building blocks for cryptocurrency? Okay. Already we have studied many, right? Hash, we know. When we say hash, is cryptographic hash. It's not the hash algorithm that you study in data structures. Cryptographic hash that we have studied in this class, right? Hash pointer and blockchain, which is extension of hash. Put hash and use linked list, then you get hash chain, right? Or blockchain. Then digital signature we have already studied. asymmetric key encryption. Asymmetric encryption we have done, right? We have studied two, RSA and Diffie-Hellman. Good. All right, very good. Now let's start. We'll something that we have not studied. We'll focus on something that we studied, which you understand very well, like digital signatures and asymmetric encryption. Will not touch. Huh? Cryptographic hash function. Please go through it. We know that from a large block of data or large size bit string or number, we reduce it to hash value, which is a fixed in size. And this is one way function, right? One wayness is there. And with very less number of collisions, almost it's very difficult to find collision. All these properties you have studied, right? Okay, note that we are not using here is MAC or something. We are just taking digest of a message or number. Clear? So this all you have studied. These slides may look familiar to you. I have taken it from the lecture, and these are the properties, right? One wayness, second pre-image, given one value of hx, x, from that you get hx, then it's very difficult to find x dash, which is same as hx. So hx dash is equal to hx. Then we say h and x dash is second pre-image. It's infeasible to find any other value which hashes into same given one value. So these are the two properties which you have studied, right? So we're not going to get into it. Okay. So basically we use cryptographic hash for integrity of message, right? Know that? Okay, so there is a message m, and then there is a hash of m. You send both reach to another end. If somebody has changed the value of m to m dash, then it will not match with h of m dash, will not match with h of m. So you can find out there is something wrong. Okay, so integrity of the message. This we have studied 100 times before. Then pointer is a data structure we know, right? You would have studied in C and many other languages, which is nothing but address of a set of memories, right? Or memory, a block of memory, right? Or it's basically a pointer points to is actually address of memory location or multiple memory location, right? So it just gives address. Okay, it just refers to another element. Okay, hash. What is hash pointer then? Okay, hash pointer is a tuple. It's basically a tuple means it has two things. First is traditional pointer, and then hash of data element is pointing to. So it's like this, that I have data element, which may be anything. It may have a lot of records or something, and then something is pointing to that. So my hash pointer will have that address. Say address, for example, is say A0, so it will be A0, and you take up the hash of this entire thing, h of that, let's assume is m, h of m, then this will also be h of m. Okay, so hash pointer has a hash value of something that's pointing to, okay, this one, and the address of that. So is a pointer and the hash value of something is pointing to, that's hash pointer. All right, any question? Now what happens if 2D modifies this block, or this something modifies here, right? Then hash of this, the entire thing will be h of m dash. Okay, and now this pointer, this value will not match with something that has been calculated earlier, which is h of m. Then we can find out that 2D has changed something inside. That's the use of this hash pointer. Okay, all right, any question? No? So this is a hash pointer, which is a pointer to data and hash of data. So it will have two elements. Okay, hash pointer will have two elements. One is pointer to the data. Of course, you know, here ideally it should be shown here is a starting point of the data, and second part is the hash value, hash of all this. You calculate the hash of this and put it here, right? Okay, so two parts: pointer to data, this address actually, and the hash value. All right, any question? Okay, so now can we create a list like this? See, what we are trying to come up is now is a blockchain concept. Okay, so what you do is that you have, okay, let's start with this one. We have set of records which you collect, or treat this as a block of data, okay, of some size, fixed size, let's assume. Okay, then what we do, then we create a hash pointer to this one. What the hash pointer will contain, it has two parts. First is the address of something from this block is starting, this is actual pointer, okay, or address. What is the second part of this? Okay, just a minute, let me put it other way, just a minute. So this is the block of data consistent of some records or something, and then we have hash pointer. Okay, it has two parts. Okay, first is address, and second is hash value. So let's assume this is address or pointer, or this is hash value. So pointer will point to this one, and hash, then what we do is that for all this we calculate the hash value and put it here. Okay, so this become hash pointer. Okay, the first block element of blockchain which Satoshi-san has created about 20 years back is this one. Now other set of people have done a lot of transaction, and then we can add to this one a record. Okay, another set. So now what will happen, that another set comes here. So I will repeat this way. Okay, now I get another one. This is a new one, and this is the old one which Satoshi-san has created. Okay, so you have data elements on this one. Okay, all right, now you have, this is the main pointer, head pointer, or head hash pointer. When we say head, it means it's a main one. Okay, so it has two elements, as we said. Address will point to this. Now this address we change it to the new block that is added. Okay, and what will happen now? Now this is the old block. What we do here is that the first one here, the topmost one, will be a hash pointer. In the newly created block, you put a hash pointer, and there are two elements, as I said. One will point to this one, and okay, and this element will be hash of this one. So effectively we take this pointer and put it here. Okay, and then you created this block, and now you do the hash in everything, including the hash pointer you have added, and then calculate the hash of this. Got it? Now you add the third block, right? So this is third block which comes new. Okay, we'll call third. This was the second, this comes here, and that comes here, these two remains the same, and now you just copy, whatever you have done it earlier here, and then you have another new head pointer which will point to this one. Okay, all right, so this is the way you work on, right? Okay, so this is the latest block that you have added. Okay, it has a hash pointer. This hash pointer has two parts. One, first points to the next block, and second is the value of hash value of all this comes here. Okay, similarly the hash pointer here, address part points to the older block, and the hash value here points to hash of all this. You get it? So as you keep getting new blocks, you keep adding this and keeps the value of the hash pointer or the head hash pointer. Okay, so you don't have to do much. You just need to add a new block. Whenever new block comes, copy to this, what was earlier. Now it means that now this block starts pointing to the older block, and create a new hash pointer, or this change the value of the original head hash pointer, which will point to this one, and hash value will be corresponding to this one. So what does it happen now? Now what happens? If let's assume that somebody Mallory changes a value here, what will the impact? Okay. So this all we have studied. So let's assume that Mallory changes something in block 1. This is the beginning block, right? Okay. This is the first block. This is the latest block. What happens? Mallory changes the value here. Anybody, please tell me.
The hash value will get changed.
Yeah. So now what will happen? This. Okay. So this, when you calculate hash of this, it will not match with this, right? It will not match with this. Okay. Let's assume that Mallory is able to change the hash value here. Okay. Now hash of all this will not match with the hash that's here. Let's assume Mallory is also not able to Mallory is able to change the hash value here, and so on and so forth, right? So as long as this is protected, you can always find out somebody has changed some data, right? So now these are the record of data over last 20 years. It could be millions of billions of records or millions of such blocks connected in a form of chain, which is visible to everyone. You can see today, you can go to blockchain site and then see the blockchain which Satoshi has created, the first block like this, and you can see almost everything. Okay, all right, but you can find out some patterns, right? But you don't know who has done the transaction, because all based on some public key. But people can look at public key and see that where the public key has got money from. It means it's got money from other public key. Okay, so that all knowledge is there, but nobody can find out beyond that. Of course, there are algorithms now which you can find out that, for example, Amazon.com has a public key which says advice you can send bitcoins to me. You can do purchases based on Bitcoin. Then people know that the particular key belongs to Amazon.com, but not beyond that. You as a user can always hide your identity, because this public key is only temporary. Okay, now question you may ask yourself that how come temporary keys is associated with me for very long, which this method answers, right? Okay, all right, so these all we have discussed now. So as we say that if this changes, then this change will be, this value will not match with the hash of this entire block, and you can always find it out. Okay. So in order to keep everything hidden, the adversary or Trudy has to change this and so on and so forth, right? But as long as we keep the head pointer, in safe place, then nobody can, right? So it takes less effort to modify a newer block than the older ones. Clear? Because if you change this one, you don't have to really worry about it, right? Okay, all right. Good. So we have done very important part. So we have studied some aspects of blockchain. Now blockchain is a data structure for Bitcoin. All right. Second thing we have already studied is digital signature, right? What do we do with digital signature? There is a document or message. Then if it's my digital signature, I generate private key or secret key and public key. And I use my secret key and cryptographic algorithm, which is symmetric key encryption. Oh, sorry, asymmetric key encryption, and encrypt this. Okay, so now we have after encryption my M as original document and T, which is my signature. Right. So now this I send. This we have studied in detail. And other end, when it goes, then message M is because it's in plain, and then can always do use my public key and create something, and then matching can be done. All right. Okay. Right. So this you take M, then encrypt it with public key, and then whatever you get is T dash. So if T dash is equal to T, then everything is okay. This method we have studied in detail, right? So I am not going to discuss it again. Only thing is the first step is generate keys, secret key and public key, then sign message with a secret key. So you get a signature, you send public key, message and signature to other end, and then person can verify document is good or not. All right. Okay, all right. So this we have studied. So we're not going to get into it. So how to use digital signature? So publish first is publish public key. So public key should be known to everyone. Then everyone can send you bitcoins. Okay, all right. And how do we generate signature? Is use secret key and create a signature. Okay, and send message and signature, and people can verify this. All right, this we know. And then digital signatures are based on RSA, discrete log signatures like Schnorr and ECDSA. We have not studied all these, right? We have just studied the concept. All right. So Bitcoin uses this one, discrete log signatures like Schnorr or ECDSA. All right. Okay. Wow. Okay. So digital signatures are used everywhere, right? And we'll study later how do we use it. It's used for transaction authorization. Okay. It used for governance votes and also used for consensus protocol votes. Now note that when we are using distributed systems, okay, and everyone has the same power, right? Then there as everything is based on voting in some sense. Okay, or consensus. They should reach everyone should reach to a consensus based on something, right? So when say for example these are miners, and you can also be miners who are busy mining mints or minting money or bitcoins, then they have to agree on certain things that I have minted, I have solved this puzzle, right? And there has to be everyone has to agree. So for all this we need when all these miners vote, then vote is based on a digital signature, right? Because otherwise anybody can fake it. Okay, all right. So all right, so when Alice or Bob does transaction, then everyone can verify this transaction using public key of that person. All right. Okay, so these are the basic building blocks that we have covered now. Okay, there may be few more. Possibly we'll discuss that when we come to the topic. Okay, now let's with this basic background knowledge, let's start with Bitcoin discussion. So a lot of words here: Bitcoin, blockchain, money, legal, cryptography. Essentially points out the same thing, that we want to achieve cryptocurrency. Bitcoin is just one type of cryptocurrency. There are many cryptocurrencies today. And then basically we want to achieve blockchain, using blockchain as a data structure. Okay, all right. This point we already studied. Today, if you hear the word called crypto, then you think of money rather than cryptography. Okay, we are not going to think in terms of encryption, decryption. A common person doesn't know about encryption, decryption, or RSA, or Diffie Hellman, etc., or cryptographic hash. So it's only you, because you have done this course, right? But otherwise, crypto means money today. Okay, all right. So now we are using these words. Cryptocurrency is completely digital, formless currency that is tied together using computer science, cryptography, and economics. This point already discussed, and there are 200 plus type of cryptocurrencies. Bitcoin is one of that, or Bitcoin is the most popular one. And blockchain, we have already studied in brief, is nothing but a data structures to create cryptocurrency. Okay, all right. There are blockchain also has some variations which we'll study later. Okay, so now a little bit of philosophy before we end. Okay, how did we move from Bitcoin, cryptocurrency, regular currency, to Bitcoin, right? And what are the features of that we'll look at it, right? Physical cash, you know, like your money, right? Your 100 rupees note or 500 rupees note. I mean, you have given it to shopkeeper, and then you don't know after that where it's gone, right? Government cannot track it. Okay, that's the reason, you know, when there is a word called black money, the use of that, you know, you don't know. Government cannot track where you got the money, where you have used the money. Okay, it's secure, low inflation, right? It can't be used online directly. So if you want to do, you have a cash, rupees, bundle of cash, then you cannot use it online. And more and more transaction we are doing online. In order to make it online, you have to deposit in bank and then use it, right? Then we have credit card and debit cards, you know, is a partially secure. These are all digital transaction and tracked by banks, right? All digital transactions that you do can be tracked, are actually tracked by bank. And then of course bank, government has understanding with banks, so government can get all the data about you. Okay, when I say government, it could be income tax department or excise department, whoever. Okay, but again, it's basically this rupee changing into digital form. Okay, and then you are doing the transaction, but there is always an entity called bank involved somewhere, right, to get the money in digital form and send the money in digital form. So bank sees all the transactions. All right, so basically, even if you use credit card, if Alice can trust Bob, now of course there is a problem here, that you know, Alice cannot share credit card number to Bob. Normal practice, right? Even is an intimate partner. But let's assume she shares credit card to Bob, then Bob can use Alice's credit card number and get the services or money from the bank. Okay. Okay, and other way is, of course, you know, transaction, normal transaction. You deposit money into a bank and give instruction to bank to transfer money to Bob, and all this can be done. But what is the problem? As we discussed earlier, Bank is always there. You have to trust the bank, and bank sees everything what you are doing. If you are not getting calls from bank today because you don't have too much money. The moment you have over say 10 lakhs or something, you every day will start getting calls. Okay, it means that bank watches you. I mean, like I have got calls sometimes. Once upon a time I had 30-40 lakhs in my account, right? And because of some transaction I've done, and I keep getting calls. I mean, I was not getting call, and then they say, that's a, can you do FD, can you do this, that, or can you buy bonds? I said, why are you getting interested? Because he says, person says that you have so much money lying in the bank. So everybody knows, every employee of the bank anywhere, if you have account in any bank, can see your account, right? So government can track that. High transaction fee and no anonymity. They know your name, your address, and everything, right? Okay. So these are everywhere. You can see the banks involved, right? Okay. Then situation was 2008, when there was a paper published by Satoshi Nakamoto. Okay. There's just one paper in 2008. Okay, about creating digital currency. Till that point, people were always thinking that how can it be peer-to-peer and so on and all that. And this beautiful paper came, and nobody knows who Satoshi is. It's anonymous. Till today, nobody knows. Okay, and that has changed the way of doing, digital currency transfer or Bitcoin transfer. They came out with concept of cryptocurrency or Bitcoin. Okay, so what are the principles of Bitcoin? What is Bitcoin? Is a cryptocurrency where rules are enforced by cryptography. Okay, point number one. Next point is not by trusted party. There is nowhere bank or government is involved. What does it mean then? I mean, you can send Bitcoins to anybody anywhere in the world without paying money, without paying transactional fees, and without anybody knowing about it. Now, there's a plus point. This plus is that you can do any kind of transaction you want anywhere in the world who accepts cryptocurrency. Negative side of all that is, cyber criminals or, all these doing in underworld, all bad people in underworld can do transaction without government tracking it. Okay. The core idea here is avoid trust in institutions, bank or governments. Okay. And don't trust merchants and credit cards. Little more about Bitcoin is a peer-to-peer cryptocurrency. It means that between any two person, Alice and Bob, can be anywhere in the world, can do this transaction, right? Is distributed decentralized digital currency system. When distributed system concept we all studied, decentralized, there is no central entity like government or bank. Okay. Satoshi San, I'm using word san or san, you use it like in Hindi or in India, in this country we use G. Okay, we'll use in Narendra Modi G, or you give respect with G. Similar in Japan, we say san is respectable. If you add san, it means that giving respect, right? So Satoshi San has developed this in 2008, and he's secretive person. Nobody knows who is it, who is he or she. Internet is the prime thing. And there is ingenious ledger used to keep track of all transactions, because transactions have to be tracked. Otherwise, anybody can forge it, right? And this transaction is called blockchain, which we have studied in very brief. Okay. Question now, biggest question is, how do you trust this ledger or this blockchain? And this is the most important problem solved by Satoshi San, a Bitcoin model. Okay, that we'll see. Study. Is a distributed ledger an associate concept? And Bitcoin is, blockchain concept existed for very long, but it became very popular once blockchain came into existence. Okay, all right. Now you can see the some numbers. If you are interested in share market, etc., you can see the value of Bitcoin every day, and people do trade. in Bitcoin, right? Bitcoin value keeps changing based on the how many people are buying and selling it. Its value also changes, right? Okay. So you can find sometimes in some countries, if government declares that Bitcoin is not valid, then you will see the value of that, the value of Bitcoin changes on that day, reduces usually, right? So Bitcoin has been fluctuating in its prices like any currency. It goes up and down. You can track it. And market cap of Bitcoin also. Market cap is nothing but how much total amount of worth it is. Okay, in terms of trading value. Okay, right? Market cap, for example, of Infosys or something is that how much shareholders are valuing it. The value of number of shares into share value at that point in time. Any question?
Sir,
Yeah.
how are we converting like actual physical money to cryptocurrency, like digital money?
Yeah, so there are a lot of ways. So
But at some
so
point it will be received by the bank, right?
yes,
So
so
it's,
so whether it's legal, illegal, that's another thing. Okay, but you can buy cryptocurrency. As an exercise, you start create a cryptocurrency account, Bitcoin account, or any other cryptocurrency account, and see, they will ask you money. So there are some agents available, right, who have already minted money and then Bitcoins, and then give you very small percentage of that to you based on the value. So there is always in the world, crypto world, value of Bitcoin associated with value of dollar. Okay, you
sir,
cannot.
but then how is it decentralized? If some agency can deny me the right to buy Bitcoin.
I mean, it's decentralized in the sense that they are always at the edge. Some people who do this transaction, who have minted the money, I have supposed one Bitcoin, which is very big value today, minted over years, and I tell you, or you say that, okay, then in this world, I can always say, crypto world, I can say, I can give you. Nobody will stop it. It's not government who will stop it, right? I will transfer part of Bitcoin to you and say that, then I will say you transfer some dollars to my account. Nobody can stop it, right? So there is always a world around crypto which will convert your dollars or rupees into cryptocurrency. Now some countries have legalized this, some countries have not legalized it, and some countries are just hanging around and watching. Okay,
Okay, sir.
all right. Why it has become so popular? Very small transaction fees. Of course, there is some fee that you have to pay, but it's very small transaction fee. Of course, you have to you have to have system, you have to have, in order to keep crypto, you have coin, you have to have some software. Okay, in order to do transaction, you have to have some software, right? And there are entities around this whole ecosystem who will help you out with this, right? Transactions are fast. This blockchain, you do a transaction, like Alice is transferring to Bob some Bitcoin. Okay, that transaction has got to go into a block. There are many such transactions, right? Okay, and then will become part of the blockchain, existing blockchain, and somebody has to validate this, right? This is all correct. Only then your transaction is included here, and it's of course done by a set of people, right? Or anybody, right, who is watching the whole game. And then it takes about 10 minutes for transaction confirmation. This number is of course reducing. Okay, so transactions are very fast compared to banks. Okay, it's accepted now in very large number of businesses, right? This is old number, 15,000 is old number. It's gone big, right? And then there is no trusted server. There's nothing like one server or set of server or on cloud. You're someplace you're doing this, right? It's not that. There's nothing. Seemingly anonymity. Seemingly means that it's based on public keys or private keys, right? And sometimes you cannot change your public key, every few seconds, like Amazon.com or some of the businesses publish to the world, this is my public key. Then people know that this is your public key. Okay, so this not 100% anonymous, but great extent is anonymous. Okay. Now this of course give transaction. What is the cost of doing transaction in Bitcoin and others? These are all businesses that accept it. Some of the businesses shown here, it could be very large number of other businesses also. Then a lot of financial institutions also accept it. You can see some big names here like Visa and so on. Okay. When we say no trusted server, we have already studied this then it means is a distributed system when everyone can join the system. And then users are not registered by any authority. Like what do you do in bank account? You have to give all the details, your name, your father's name, who's your spouse, what is your income, what is your email address, what is your PAN card, Aadhaar, and all that, right? Based on that, bank will open it, and still they may want some more things like letter from your head of department and all that, right, or institute. But crypto, you can do it today. Nobody is going to stop it, and you could be anybody. It's not associated with name. Okay, it's not associated with any name, right? And it's peer-to-peer network. There's no trusted server, has many advantages. Nobody controls, and hence the amount of money that can ever be printed is fixed. So there's no inflation. Why? I will give this exercise to you to find it out. Okay. When is no trusted server, but there is a client software available. Okay, all right. And a lot of companies are there in this ecosystem who develop this software because you need some software to use a coin, right? So if you have cryptocurrency, and if let's assume that you forget your keys, right? These keys are 256 bits long. What will happen? Anyone? I mean, you would have read in newspaper, right? Some guy has lost close to 1 million, equivalent to $1 million, because the person forgot the key. Okay. Now, question that I'm asking is somebody generating key for you? Then that person knows. Somebody has to generate private key and public key, right? Is third person, any agency is doing this? If that person knows your private key, then can do all the transaction. Now in crypto world, it is you who is generating your SK and PK. Now the question that you may ask is that if I am generating my SK and PK, can there anybody in the world at that point in time have same SK and PK? Yes. Then how do you solve this problem? That's the question. Okay, all right. Just another minute and then we'll close it. Okay, this is not that important. So Satoshi-san came out with this beautiful concept. Please read through it. If you have time later, you read also through this one. Okay. And there are a lot of skeptics who say that this is all fake. Don't use it, right? There are some says that, yeah, it gives me a lot of power. Why shouldn't I use it? Right? Ultimately, is the it's you're spending a lot of clock cycles. So somebody has spent clock cycles to generate this mints, right? Or minted this money, so it's valuable, right? Okay. So other thing is that I want to go through is Merkle tree, which is a more efficient data structure for creating blockchain, right? So here, see in blockchain, you know that is a linked list, right? Singly linked list. If you have done data structures course, if there are n nodes, and you have to search something or you have to validate up to the first data structure which Satoshi-san has created, first block, then you have to spend order and time, steps, right? Now, and better data structure is a binary tree, which is based on order, log, and search time, right? You would have done this course on data structures. So now here you have data element here. Consider this a block. The second one, third, and fourth. You can create a pointer here and do hash of this data, right? So you have two elements here, address or pointer and data, and then use these two, and then again you create. So take this hash value here, the hash value corresponding to data here, and then create another hash, and so on and so forth. So this becomes a head hash pointer. So now if you have to do search, your search space is reduced to a small area, right? So now you are going to do order, log, and steps. Please go through it. It's very important data structure. It's called Merkle trees. If you have done data structures course, you understand by now what I'm telling you. Okay, so we'll stop here. Next class we will look at this public key, private key concept. Okay, and then how can we do transactions? Okay, all right. Any question?